Hey folks, it's always exciting to be invited to these things. I've discovered that the trick is getting invited back, so we'll see how this goes and whether folks actually want to talk to me again. So yeah, by way of background, I'm the CEO of Heptio. It's a little startup. We're about this high, trying to grow up. And we've been in business for about 7 months, and our sort of mission is to bring Kubernetes to enterprises with a relentless focus on increasing the size of the community, making the technology more intrinsically accessible, and stitching it into the fabric that runs modern businesses. And I'm going to spend a little bit of this evening talking about the technology itself. I'd just like a show of hands. How many of you are familiar with Kubernetes? Great. How many of you are running Kubernetes in production? Awesome. So some of you don't know the system. And I will just spend a little bit of time talking about what we were trying to do with Kubernetes. And in particular, what I'd like to do is relate some of the concepts to the things that we learned as we were building some of the technologies inside Google. And the starting point, whenever I like to broach a topic with folks, is to help them understand how I think about the space just a little bit. And when you look at the world of enterprise software, and you look at the way that software is driving and creating transformational capabilities for pretty much every business. And, people say software is eating the world, and it really is a critical function for modern enterprise. And a lot of modern businesses are starting to self-identify as technology companies. I bet you if you asked AppNexus, they would say we're a technology company. I mean, they're also an advertising company, but it's so intrinsic to the business they do. And I think that's becoming increasingly true of more traditional brick-and-mortar type shops. And obviously, cloud computing is fundamentally changing the way that people experience technology. It's quite interesting because a lot of people think about cloud computing as a way to just provide some basic hardware infrastructure. But there's some really profound changes that it brings to your operational posture. And there's a lot to be learned by looking inside the way that the internet vendors are actually delivering this technology and thinking about how you can apply that back into your own life and how you can manage your own applications and build them and run them. And then the last piece of this is, obviously open source is kind of eating the software industry. It's becoming increasingly important to organizations that they're able to get closer to the technology that runs their business. So they want to bet on something, and turns out it's better to bet on something that isn't tied to a single vendor. It's better to bet on something where if you really, really need something, you can probably fix it yourself if you're sufficiently sophisticated, and have a decent shot of the upstream community accepting what you're doing. And so we spent a lot of time thinking about this as we were starting the Kubernetes project. And for us, Kubernetes is just the seed crystal of this bigger transformation. And I look at Kubernetes as being this necessary part en route to this broader set of outcomes for developers that we call in cloud native computing. And to be fair, I think that I kind of conscripted the term from Pivotal, and I feel a little bit bad about that because they'd been using cloud native to describe this normal idea of 12-factor applications, stateless front ends, and a bunch of other things. We've started to think about cloud native as something that's a little different. It obviously encompasses a lot of the patterns that we've seen other organizations characterize around cloud computing. And at the heart of it, it comes down to these sort of 3 organizing principles. It's really about containers, orchestrators, microservices. But it's a lot more nuanced than that. I don't think you can look at something and say, hey, it has these 3 attributes, it's cloud native. To me, it's thinking about deriving some of the principles that the cloud providers have pioneered, taking the principles that have been created at a lot of the internet companies and looking at the way that they tend to build applications. And as a result of these changes and this new way of thinking about the world, you get things like an order of magnitude more efficiency. This is a true story. This really happened to me. So I built a product inside Google called Google Compute Engine. And I remember going to the Google infrastructure provisioning folks and saying, hey, we sold out all of our compute resources. We need more compute resources because people like our product. And they came back to us and said, no, you can't have any. I was like, why not? And they were, because you're only using 7% of the CPU we gave you. Until you actually use all the computers we're giving you, why would we give you more? I was like, because we're selling an infrastructure as a service product. We don't want to oversubscribe. People are paying for all the computers that you gave us. why would we be concerned about it? And we had a long backwards and forwards and eventually got more additional resources. But the reality is there was effectively an order of magnitude difference between what a customer using a traditional infrastructure as a service product in a relatively naive way could get out of that piece of infrastructure versus what Google could get out of it with Borg. So that's like one order of magnitude there, and that's kind of interesting. Now, realistically, as I see people kind of making this transition to Kubernetes, don't expect 10x, right? But you can predictably expect something about 50 to 80% cost reductions on your AWS builds. Like, I don't know if that's what you've seen as you've actually made the transition, but it's certainly what a lot of our customers are seeing in that sort of in that order. The thing that's more exciting, though, is not just infrastructure. It depends on how big you are and how sophisticated you are and how much infrastructure you're consuming. And I bet you there's a lot of people out here who are actually spending a decent chunk of change on infrastructure. But for most modern organizations, the high order bit, the thing that's holding them back the most is the developer productivity. The ability to get their developers to actually move faster, get closer to the business, and deliver technology in a sort of more incremental fashion. The thing that's fascinating about this is seeing this sort of 2 orders of magnitude improvement in terms of team agility. Seeing a lot of shops go from these kind of crazy 3-month development cycles where they do this sort of Herculean push technology over the wall and throw it at the business, and then they just hope they can catch it, right? Moving to daily integration cycles, being able to run experiments, becoming much more sophisticated. And a lot of these patterns have existed for a long time. It's not necessarily new. They've been inside the internet companies, and they were used to solve problems that were unique to the internet scale companies. Like inside Google, if you look back about a decade or so before Borg existed, it was basically all we could do to keep the lights on. It was really hard to launch a new production service. And you always had these kind of really tough choices to make, like, what do I deprovision to reprovision this? Oh my God, there's a success disaster. What are we going to do to actually get the capacity? And then through the introduction of technologies like Borg, it really changed the game. Like, everything became just a whole bunch easier. And we started to see things like a doubling in the number of production servers that are being run. And so much of this is a result of being able to start treating your infrastructure as a logical resource and as a way to accelerate your developers rather than something you're constantly struggling with and dealing with a lot of toil. And you're probably saying to yourself, but wait a minute, maybe some of you do have internet scale problems, but a lot of people are like, well, I might be in a different space. I just don't have internet scale problems. Why do I care about this? Turns out those same patterns of dealing with complexity of scale also deal with complexity of heterogeneity. It lets you get your arms around a much broader technology set and create a more reasonable way to think about it. And even if you're producing something relatively modest, it takes a lot of the toil out of your game. So it's not just about solving for scale, it's about solving for complexity and driving down the cost of your operations. A lot of people are starting to use this term zero ops. Anyone who says zero ops, just say you're selling something, right? Ops doesn't go away, right? But what you can do if you start thinking about this is, what does an operations power tool look like? How do I create specialized operations teams that become expert at delivering technologies and save my developers from toil? And so that's kind of what the speech is about. So I'm going to step back a little bit and walk this through with you in some pieces. I'm going to tell you the story of containers as I experienced them, right? Now, it turns out containers have been around since forever, right? Like, this is not a new technology. The current incarnation of containers, everyone's probably heard of Docker. Who hasn't heard of Docker? Right, I don't see a... Good Lord. You should get out more. But Docker is obviously the modern manifestation of Linux application containers. And if you trace the history back to where the sort of technology started, you can go all the way back to Google, interestingly enough, with a technology called C groups, which used to be this kind of super secret internal source, which was a way to increase the level of control that you could have around assigning resources to a set of processes. So you could now take a set of processes and you could say you can have this much CPU, this much memory, this much whatever, and achieve very high levels of resource isolation, which was super neat if you wanted to run at internet scale, because you wanted to have a very efficient way to drop a lot of different things into a lot of different physical machines and then tune how much resource they could have so they didn't preempt each other and they didn't stumble all over each other. And of course, Google has always been invested in open source technologies. So a pretty obvious thing was to take the C groups technology and push it upstream. In part because Google's always been invested in that, but also in part because it gets really tiring trying to maintain that deep of a patch on the Linux kernel. Like it just gets quite wearisome. And so C groups became part of the Linux kernel after Google really explained what they were doing. And some really smart folks started thinking about like, well, what else could we do with this? And they came up with the idea of Linux namespaces, which is a way to take a set of resources and create that sort of personal experience inside the Linux kernel. It creates something that feels like application-level virtualization, where each process gets a set of name system resources, but it feels like a unique copy of that, and it's all built around the C groups infrastructure. And that led to AlexC. And AlexC was a simple userland wrapper that just made the namespace kernel features more accessible to developers. Right? So it was the lowest effort way to get access to these containers. And all of this was like rooted in the idea that people like Google wanted to be able to run a lot of things at scale at relatively low cost. And this all became very exciting during the kind of PaaS craze that happened a little while back. And there was this little PaaS company called .cloud. Who remembers .cloud? Okay, two. .cloud was a PaaS, and they solved a problem, which was how to package a piece of application code using a layered file system, relying on the Linux kernel as an abstraction layer, built around the AlexC code base, which sounds a lot like Docker. And eventually they renamed themselves to be Docker, and that's how Docker was born. And it was really about solving this one very specific problem. But Docker did something amazing. And I have so much respect for this, because I'd been thinking about the same stuff at about the same time. And so Docker, I just kicked myself, like, oh my God, it's brilliant. They put lightning in a bottle. They leaned into the Linux syscall as being this beautifully consistent thing that exists across all flavors of Linux. And Linus Torvalds stands between userland and chaos, right? You break userland, I'll break your head or whatever. I can't remember what he says, but something like that. And so that was thing one. Thing two was composability, being able to find something very quickly, take it, layer a couple more things on, bake it up as a big old tar file, and get it out there into production, right? Huge. And then just this elegant developer toolchain, this very neat experience. So you had portability, you had composability, and you had a really neat experience, and Docker's magic. So when we were sort of, this is kind of back to a personal story, Joe and I built this product called Compute Engine, and we had a product called App Engine, and we had a product called Borg, and we were working on a product called Omega, and we were trying to kind of get our brains around all of this stuff. Because once we got done with Compute Engine, we already started thinking about this compute continuum and trying to page all of this stuff in. And we knew that we wanted to create that wonderful Borg experience, and we knew that because I remember us proudly displaying Compute Engine to one of our execs, and we sat down and we were like, watch this. We started a VM instance. 30 seconds later, it pops up. We're like, oh my God, how fast is that? And they were like, huh, now what? We're like, well, we have a VM, right? Watch this. I SSH in, I can app get this and this and this. And they're like, why would I do that? Why would I just run a job? Just tell it what to do and have it do it, like Borg. This is stupid. And it's funny how the whole culture becomes so insular, where people are so abstracted away from the mechanics of actually dealing with these basic operational toil activities. And so we were like, that's kind of interesting. And then we also saw this big chasm that existed between platform as a service and infrastructure as a service. It was very hard for people to actually deal with these two things. A lot of people would find something like App Engine, and they would freaking love it, right? Because I write some code, I press a button, it just runs. It's great. Snapchat is built on it. It works really well if you're Snapchat. But turns out there's some things it just doesn't do. And you get this kind of experiential cliff. And then you have to go and walk in there, and it's like, oh gosh, I can't run Elastics, something in the space. So I have to put in a VM. And so how do I get in a VM? Well, I could try to bake an image, or maybe I'll use some Chef, so go learn Chef. And then I get to a point where eventually I'm like, well, hang on, if I'm already using all of these like low-state configuration management primitives. Why wouldn't I just take the code and deploy it within the same stuff? So we were seeing people coming in and kind of falling out the back end of PaaS into infrastructure. And it was a long drop down, right? It's very uncomfortable. And so we're trying to find ways to smooth that continuum. And of course, Joe came along and found Docker before it was hip. And I remember looking at it, and we had a product in the market called Let Me Contain That For You, which is, it was a mouthful, but it was also a pretty powerful Linux application container technology. But it was clear that if we bet on that, we'd end up owning the Betamax to Docker's VHS, right? Like, there would be enough interest in the market around what they'd done. So even if the underlying technology was better, there was no practical way that we would get there because their experience was so amazingly good. But we also knew that the problem didn't end at getting a container onto machine. We had this kind of, it's like what my friend Brennan, who was kind of one of us, always said, like, it's like we had the puzzle box and we're trying to assemble the puzzle. It's a lot easier if you know what the picture is. And we had Borg in front of us, and we were able to start putting that together. And then obviously came up with the idea that open source really matters. Community really matters. We were not an enterprise company. We were an internet company. And if we wanted to get the enterprise DNA into the mix, we needed to work with the enterprise companies. So just doing this whole thing as open source was a kind of crazy idea, but it made sense. And so we came up with Kubernetes. And we focused a lot on the things that we learned from watching applications being built and run inside Google. So again, we were cheating. We were standing on the backs of giants, and it gave us a perspective that I think a lot of other people would have struggled to have. And we were obviously standing on the backs of Docker as well, who created this amazing developer experience. And now we were saying, hey, that's great for the first 5 hours. Let's worry about the next 5 years. Let's really start thinking about how to make these things applicable. And for us, it started with this idea that we had to get the domain model right. And we had a cheat code, which was what was inside Google. And one of the things we noticed is that people outside Google started treating these containers as VMs. And they were like, oh, we're going to kill VMware because containers are better VMs, right? They're cheaper and we don't have to pay for them because they're free, because it's open source, right? The reality is a container isn't a VM. And if you treat a container like a VM, you're leaving so much value on the table. So let me ask another one of my kind of like hip technology questions. How many of you have heard of Istio? Istio, okay, great. So Istio is a new service mesh technology that Google just announced. And it's really neat stuff. It allows you to, inside something like a Kubernetes cluster, effortlessly and securely wire together containers and just have client-side proxies handle all the routing and cross-service authentication. So it's like a full-bore service mesh built on Envoy. Turns out if you want to wire it in, you would either need to do something fancy to kind of link it into your code so it loads in your process space, or because you're using C groups, you can just wire it in as a sidecar container that runs in the same process space as everything else you're doing. And so we came up with this conclusion that containers are lonely when they're by themselves. Composability and mixability is an essential part of the story. And we'd seen this because obviously we had the puzzle box. And so one of the core initiating concepts for Kubernetes is this idea of a pod. That rather than thinking about an atomic deployment as a single container, you think about it as a container collective that have shared fate and have access to shared resources. And this allows you to do some really neat things around structuring your application. You can run your web serving front end that's doing HTTP request response for real-time bidding in a different isolation group, resource isolation group from, it have access to the same basic underlying resources, so it can share memory with something that's doing like a data shard update. So if you wanted to go ahead and get the bidding tables updated dynamically from in-memory, you probably don't want the update process preempting some real-time bidding requests. You probably want to be able to make sure that it is scheduled and runs, but maybe during sort of lulls. And so you can co-schedule these things and make sure they don't preempt each other. And as a result, you get to a point where you have far higher resource utilization. The next pattern that we obsessed about inside Kubernetes was this idea of distributed control. So in many ways, I attribute this to my friend Brennan, who was both a college professor and a robotics nut. And he obsessed about control systems and how to think about control systems. And we also had that pattern where if you start getting to a point of scale, you're far better served by like radically decentralized control patterns. We have an autonomous entity that has a relatively isolated span of control and the things it's observing over, and you tie it loose to drive that thing into a known state. And so this introduced the idea of replica sets inside Kubernetes. We originally called them replication controllers. But the idea here is that if you're trying to rely on a system that's going to drive your application to a known good state, and so much of this is just a control theory problem, there's things that autonomous controllers do better than people. And the reason I paint a picture of a drone here is that, and this still traumatizes me, right? So this is kind of like a little sad part of my childhood. I had one of those little balsa wood planes. I loved that thing. You could do loops and all kinds of crazy stuff. And then one day there was an oops, and it was 10,000 pieces of balsa wood across a sports field, right? Because they're hard to fly. And compare that to a modern drone, where it's driven by intent. It's not driven by input. It's declarative, not imperative. You tell it what you want to have happen, and it tirelessly watches it at a level of fidelity and acuity that you could not possibly achieve as a human operator. So why aren't we applying this pattern to running our own applications inside an organization? And that's a big part of what Kubernetes brings, is this idea that there's some things that computers do just better than people, and one of those is tirelessly watching your application and making sure it's in the right state. And then being able to do something about it, not just alert. Right? Alerting's easy. Autonomous remediation. And it's funny, because I actually think in some ways Kubernetes is causing us to write worse code, because it becomes so much more forgiving of things like out-of-memory conditions. And it'll sort of seamlessly recover, and you just don't get paged as much. So that's something to watch out for as you make this transition. The next thing I'd like to talk about is this idea of deployments. So this is a first-class object inside Kubernetes. And one of the things we see people wanting to do organizationally is be able to bring these much more mature operations patterns to their applications. I want to run an application, and I want to be able to do some really interesting updates. I want to be able to do a rolling update with zero downtime. Like, try doing that with traditional VMs and see how easy it is. I mean, you can do things with load balancers, you can do things with DNS redirect. There's tips and techniques you can do. But the beautiful thing with Kubernetes is you can say, go from this state to that state, go. And you have a first-class object that lets you actually move yourself from one state to another state, and then if you don't like it, you can roll it back. And you can run experiments, and you can do all kinds of fascinating things. And it is stress-free. It is so nice, because the old moments of extreme anxiety that you'd get around any kind of update become much more deterministic. You're rolling out containers. It's a binary copy. It doesn't go wrong all that often. You have an opportunity to get configuration pushed into it. I'll tell you how that happens in a second. That doesn't go that wrong all that often. And then you have a deterministic mechanism that's watching the health of these things, making sure they're healthy before it gets wired into your serving fabric. It's really powerful. The other thing that we learn inside Google is that hierarchy is the path to madness. When I think about some of the work I've done outside Google, I think I've sat down with probably at least 100 systems architects. And I've asked them to just draw their system. Like, show me what it looks like. What does your system look like? And the only thing that was consistent is they all drew lines and boxes. Like, that was it. Like, there was nothing else in terms of the level, the hierarchy, the way they structured things, the relationship between the pieces. It's just lines and boxes. And a lot of people fall in love with this idea of forced hierarchy as a way to kind of create structure. And that's dangerous because it's difficult to fit that into your world. But there's a more nuanced thing here, which is having the ability for a user to describe something on their own terms, and having that label drive semantic meaning for the underlying infrastructure. So you call something a front end, it's a front end. You can say, update my front end. You're achieving and retaining semantic meaning, and you're carrying that forwards into your operations environment. And that's a very powerful way to do this, particularly when you start to think about the way that all of Kubernetes is grounded around these label-driven selectors. So if you want to include something in a service construct, you throw it on a label, and suddenly that thing is part of the service. You want to take something out of the serving path, you pull the label, and suddenly that thing is out of the serving path. And the nice thing, again, is that that label can then still retain semantic meaning that you assign to it, and let you start bringing semantic meaning into your operations profile. Having said all of that, a service is kind of important. A lot of Kubernetes is about these dynamic entities that come and go and are scaled up and scaled down. Some may be singleton, in the case where you just want to run one of something, that's entirely achievable. But often as not, a lot of the components that people are deploying in these systems are relatively transient. It could be related to a job. It could be something that is scaled directly proportional to load. And if you want to introduce transient entities into a distributed system, you kind of need a structured way to address them and think of them as a collective. And so Kubernetes introduced this idea of a service, which gives you a durably named static thing that proxies for all of the underlying replicas that are sort of part of one of these replica sets. And you can talk to another one of these services directly as if it's an endpoint, and then have everything routed out through under it. They're discoverable through DNS, and there's actually a first-class API that lets you get at the services. And again, it's all label-driven. So you put a label on something, it's part of that service membership, you pull the label, it goes away. State matters, turns out. We like to write things down and be able to find them again later. And a lot of people have been pitching this idea of the perfect 12-factor application notion. And that's lovely, but again, you get to the end of 12-factor and you have that kind of drop down, and the landing place is infrastructure as a service, and it's sometimes not too comfortable. There's a lot of work being done to make sure that state works well in Kubernetes. As you look to the upcoming releases, a significant amount of resources being put into this by the community, and I expect to see a lot more maturity around the way that we're able to map volumes into pods, and maintain a decent connection back to for the workloads that are actually initiating those. And so for us, a volume is just a shared file space for all of the containers that exist inside a pod. And there's a lot of ways to map that in. iSCSI, pretty much any of the block devices you might think to name, and then you can just map to local resources as well. And then another kind of key point here, just in the Kubernetes space, and I'm going to make a transition to talk a little bit more about ops, is the idea that you have to tell the container what it is, right? You boot up this thing, it's a pristine static image, but it needs some clue as to what it's supposed to be doing and how it's going to fit into the universe and how to actually achieve its configuration. And so Kubernetes introduces this idea of a config map, which is a nice way to separate out the configuration that the container needs, and it can just be read as a volume. So it's a dynamic resource, you can set it through API, mount it into that space, and then you can read out your configuration when the container boots. And the other piece of that is a thing we call secrets, which is a more secure config map that's already used to present identity and help containers establish identity, by receiving key material or other secrets. And so that kind of ties together the system, and it's a bit of a sort of very fast path through, and I'm kind of describing the elephant by the various parts of it. But I hope you at least get a sense of some of the attributes of Kubernetes, and more importantly, why we drove it the way we did when we were building it. I'm going to talk about another, and in my mind, even more exciting. I love operations. It makes me so happy and excited to think about ops, primarily as a way of just driving down toil. I think that we spend a lot of time thinking about development, and we don't spend enough time reasoning about how to actually get the toil out of our lives. We think we obsess about code, and we often we don't even see the toilsome tasks that are holding us back from actually writing code. And the heart of it is ops. And so if you think about the evolution of ops, there's this whole path the world that has gone through. First of all, there were computers and there were mainframe coders, and they would just write programs, deploy them, get them scheduled to run, and everything was great. You didn't need a separate operator. The operator was the programmer, and the programs are pretty simple. But pretty soon we got to a point where we had client-server technologies. We started to have scale-out farms of servers, and the developers were just like, they'd mess it up, right? It would be crazy if you just gave your developers access to production resources. And so it made sense to have this craftsman in the mix, this person that could take a server and craft this beautiful, pristine, incredibly curated, production-ready thing. We call them a system administrator. And they're an operator, and the world is the ticket. Like the system administrator receives a ticket, and they're like, hey, I need to build a blah. And they go ahead and they craft it. I receive another ticket, hey, I need to update the blah. And then they do this. And it's meticulous work. And like, I love them because they're craftsmen. But it's hard, and it scales very poorly because it's a human-initiated activity. And it makes people sad because they have to wait for stuff. And that's not good. And so we invented DevOps. Like, developers are awesome. They can code the hell out of anything, right? Let's get them to code the hell out of these production problems that we have. We're going to give them one set of tools to write their code. I'm going to write some Java. I'm going to give them another set of tools. I'm going to write some Puppet or Chef, and I'm going to code the hell out of getting this stuff into production. That's kind of like the one-man band, right? So you like play all the instruments and you do everything that you need to do. The problem with that, obviously, is well, let's not talk about the problem. It's great. It's actually solved a whole bunch of problems. Like it's moved things forwards because you actually have an imperative piece of code that's running in production and driving your production machine into a state that you want it to be in based on a recipe. And it's taken the world from this world where you'd file a ticket to a point where you can run an integration. And it's a big deal. And it's actually moved us forwards as an industry considerably. Problem is, it works, except when it doesn't. And when it doesn't work, it really doesn't work. If you think about what you're doing with a lot of the DevOps tools, is you're running imperative code in production. The tools are only as strong as the model. Things you can't model, things you can't describe, you can't drive to a known state. It has a lot of moving parts, and a lot of those moving parts happen in the production environment. And it doubles your toolbox size. So you're a developer, and I've had this conversation with many CIOs where they're like, we love Chef, but our biggest problem is that it's a lot easier for us to find Java developers than it is to find Chef developers. And we're actually backed up on our DevOps pipeline in terms of being able to get a lot of our pieces into production, which is kind of weird. You lose some degree of visibility and control. You know, like it or not, the strength of the platform is only as strong as the model, and you're relying on these processes to actually, craft something from a base model in the final production environment, which is sometimes a little bit dubious. And so it brings us to this world of cloud-native operations. And so I think Kubernetes is a tool that gets us there. And it's kind of like this transition to the assembly line, where you're no longer, the assembly line's maybe not a great analogy. I don't actually know how to make that analogy really work. But we're moving to a world where we take an application, and rather than trying to deploy it to physical infrastructure, we've crafted this logical ideal of what your infrastructure should look like. What would the perfect computer be? Well, it would be constructed of a large number of small, cheap machines where if one failed, I don't care. It would be a computer where I say, hey, deploy this and run it, and it just deploys it and it runs it. And when I want to update it, I just say, update it. And it only works because with Docker, we're now able to describe the thing that's running perfectly as a simple static image. So Docker's made all of this possible. Linux application containers and whatever you will, but Docker made the experience that actually has allowed us to get here as an industry, and we have to be appreciative of that. And at the heart of it, what this has led us to do is get to a world where the atom works an API call. We're no longer thinking about a world where we're filing a ticket or we necessarily have to run a full integration. If we want something to happen, like we can cause something to be provisioned by making an API call. This is why I call it cloud native, because this is what happens in the cloud. Like, hey, I want an RDS instance. I make an API call. Maybe I use the dashboard, but at the end of the day, I can still provision things through APIs. And it scales effortlessly. This is why the internet companies can be internet companies, is because they have technologies like this to solve those problems. It creates repeatability, and it removes toil from the developer's life. Because the system they're interacting with is no longer infuriating. It's no longer obnoxious. It actually has a very simplistic, deterministic, declarative interface that you can work with to make things go. Of course, it is new. And new is scary. But it's also exciting, right? Like it's fun to work with new things. But it's relatively nascent. And so as we think about our journey towards this cloud-native computing paradigm, technologies like Kubernetes are actually pretty mature. They're making a lot of progress. But there's a lot of other things that we need to build as a community and as an industry to make this real. So we need to increase the introspectability, the debuggability, the diagnosability. We need to wire in the monitoring systems. We need to get this integrated into a lot of the traditional ticketing systems. We need to start thinking about the power tools that an SRE would need to operate in this world. And so It is new, but it has some really powerful attributes. And I don't want to kind of spend too much time digging in here, but you get to this world where the applications are now deployed into logical infrastructure. So like the rainbow, unicorn, cloud native ops analogy. But at the heart of it, automation replaces toil. And this is a mindset that the SRE, the site reliability engineer, the expert operator has to get into. It's like, I'm going to be lazy tomorrow. Like, today, I'm going to do a little bit more automation so that tomorrow I can be lazier. And working on a platform like this really creates a force multiplier for the use of automation to replace toil in your day-to-day activities. It creates opportunities around smart specialization of roles. So you can rely on one set of people in your organization to create this thing. And then they deliver this as a service to another set of people. Those people can then use it to deliver service to another set of people. And that specialization carries us forward a long way. It provides access to these shared application level services. So how many of you self-identify as full stack developers? As what? Full stack developers. Right, I hate that term too, and I'm sorry. And they don't know anything about this. And the issue is that it's so freaking hard, right? Like, to be a full stack developer, you have to be an expert DBA, you have to be able to provision, you have to be able to do all of these other things. It's so much nicer to have your friend be like, you are the Postgres monster. You understand this stuff better than anyone. Like, if anything gets weird, you can diagnose it and resolve it in minutes, when it would take me hours, right? That's the guy or gal you want to run your Postgres. You don't want to do it yourself. Like, that's crazy. And so shared application level services, can go beyond just a service like Postgres. It can also be things that you rely on for your own code at a much more simple level. Like, I don't know how many people in this room have implemented a ROF protocol, but it's nutso, and it's hard to get right. Like, why wouldn't we just have quoruming and distributed locking as part of our natural development fabric? And so these types of things can become available as common services in this logical compute environment. And then, pardon? Exactly, chubby. That's a big part of the kind of broad ecosystem. And then intelligent subsystems drive optimization. So as you get into this world of operations, it's like that drone. There's some things machines just do better than people. They can make better moment-to-moment decisions. They never get tired. They don't get distracted. They don't miss issues. And they can create far better optimizations. As we see the emergence of machine learning in this space, it's going to get really kind of interesting. So through this, we're going to start to see new operations roles emerge. We're going to see people that are just good at infrastructure operations, like wearing rollerblades, getting around data centers, racking and stacking, fixing hardware problems. We're going to start to see cluster operations engineers emerge who can take together a large amount of physical infrastructure and turn it into something that is useful to a very wide number of people that create that logical infrastructure experience. And all the way up the stack, the people that actually deliver common services that are provisioned through an API that are integrated in an effortless way into this cluster environment. The application operators who maybe can take some of the load off the application developers, and then the app developers themselves. Or you could wear all of these hats if you're in a small organization. There's no reason why one person couldn't cover all these roles. But you have the option to actually specialize, and that's kind of powerful. And it also leads to this new expert operations mindset, where as you narrow the focus of attention, you get to be really freaking good at something, right? And you get the SREs, and they're badass. Like, they're really good at their job. And when they're not doing their job, they're drinking, because they like to drink. And it is an expert mindset. And because you're able to focus on driving down toil, because you're able to focus on a relatively narrow scope of area, you get really good at what you're doing. You create efficiencies for yourself. You automate yourself out of a job as much as you can. And that then frees you up to do other things that people wouldn't do. Like, how many people in this room are really kind of passionate about service level monitoring? Now, not just passionate about is the service up or not, but monitoring, latency at 3 different standard deviations or 4 different standard deviations. Managing, observing occupancy, trying to understand what the sort of lead signal indicators on scaling events are, really digging into these deeper operational narratives. And how many people have the time to actually put together an incident response playbook? Where what I'm going to do today, I'm going to sit and write down all the steps it would take for me to get the system back up and running if it disappeared tomorrow. Like, no one has time for that unless it's their job. That's a first-class thing. And then who actually runs that playbook? Who will shoot something and see if they can get back up, right? That's the mindset. And doing that for a specific service inside an organization actually creates a tremendous amount of power. And then the next part of this is, it's not enough to just think about the operations. You also have to start thinking about creating structure inside your technology space that leads you naturally to this world. And I tend to think about this as the sort of evolution of composition and sharing, right? So today you may have code that's bundled up in a VM image and just replicated out all over creation. And a logical first step is to start looking at the composition of your images and decide, do all these things need to be bundled together? I mean, maybe they all need to run in the same process space, but can I at least start separating them out? So that if something goes crazy, it can be restarted without tearing down everything else, within the parameters of isolation, resource isolation, so that I can update something without having to tear down everything else. So the first step towards getting towards this new way of thinking about the world is looking at like a local atom of deployment and starting to ask yourself some questions around like, does this all need to be in the same thing? Is there an obvious way to start teasing it apart? Let's go to containers, let's go to composed pods where the pieces are there. Now you can start thinking about like, okay, done that. Like, how much of this is commonly reused? Can I put one of these things behind a stable interface so that it no longer has to be deployed into the same process space? And now I have an opportunity to effectively decouple them. And when I say stable interface, I don't mean like, don't go build a microlithic application. I always call these people like do this microservice and you ask them the question, when you update that thing, how many other things do you have to update? And they're like, 8. I'm like, that is not a microservice, right? It's a monolith that you've just stitched together out of like crazy stuff, and it's going to hurt you, and you're going to hate yourself, right? Stable interfaces are really freaking important, right? Like, I often think it's the kind of 13th factor in the sort of 12-factor stuff, but figure out those stable interfaces, and then start thinking about promoting some chunks of that into repeatable local services. So I might have my little cluster environment here, and I'm like, you know what? I'm doing a lot of this one thing. It's factored out. It's part of a stable interface. Maybe I can turn that into and promote it into service, and then maybe I can promote that into an heroic service that's available to my entire organization and run by expert people. So there's this clear path you can take if you start thinking about it as this sort of progressive decomposition set of activities, and don't be overly aggressive about decomposition. There's no reason to just try to tear everything up. But each point of aggregation allows operation specialization. It gets you closer to this pattern of operations, which is neat. And then, I always love the superheroes, but what you get to here is a different shaped team. You no longer have to, as you do with the full stack developer, have this perfectly well-rounded athlete that can do the decathlon. They can do all of the events, right? You start to enable people to actually identify a superpower. Like, I don't want 8 Batmen. Like, I want the Avengers. I want the whole thing, right? I want Wonder Woman. Like, this is not, this is the path to get there. And think about Conway's Law as a great example of this. This is the speculation that if you start thinking about organization and architecture almost always follows the lines of team communication structures. And so when we get into this world, we can actually start to think about crafting much smaller, more atomic teams that are able to stand on the shoulders of giants, leverage out all these services, and by doing so become far more efficient, far more agile, and far closer connected to the business. And at the end of the day, just kind of wrapping up this whole presentation, I've been kind of monologuing at you for a little bit, and it'd be nice to hear some questions, is the impact of cloud-native operations is considerable. You see this organizational efficiency is probably the most significant thing, right? You get more efficient infrastructure utilization, 50%, 80% in some cases that are pretty extreme. More agile systems, and then technology just gets easier to access. The barriers to access are lower for a large portion of your development organization. And admittedly, there is some complexity and fanciness here. Like, Kubernetes is a relatively complex system. It takes a while to understand it. But once you get over that energy curve, and once you've actually made this transition to the cloud-native computing paradigm, you're in pretty good shape. And the way I kind of wanted to wrap this sort of session up was just talking a little bit about getting involved in the open source community. Open source really matters. I think that it's a lovely way to really, one of the best ways to understand the technology that you're betting the business on is to actually work in the open source community on the technology you're betting the business on. It's really nice to know that if things get really weird, you can turn a patch, that you have some familiarity with the technology. And so I definitely encourage folks to think about this community. It's a big community, it's a healthy community, it's a powerful community. We're working very hard to kind of tease it apart into smaller, more composite units because it's very big. But it matters. And the other thing I would say is that we focused, as we were building out this community, on making sure that we had a very balanced posture from an IP management perspective, so that no single vendor would be too empowered, and that we'd avoid some of the balkanization we've seen in other communities. So when I was putting the Cloud Native Computing Foundation together, I was actually just getting my US citizenship. So I was geeking completely on the sort of separation of powers and the way to actually create structured governance through separation of responsibilities. And so we modeled the foundation on that, right? You have the business board, which is kind of like, in some ways, the executive branch, I guess. You have the technical oversight committee, which is something like the judicial branch. And then you have the end user community, which is kind of like the house, right? And we wanted to create this sort of separation and dynamic tension. And it's actually worked out pretty well insofar as we've maintained coherence, we've established identity, we're actually moving forward as a foundation. And the foundation is a lot bigger than Kubernetes right now. We've actually started pulling through a whole bunch of adjacencies. There's like 9 projects, which is really cool. Think about getting closer to the community. The closer you are to upstream, the less locked in you are, as I'm going to say about that. And the distro model isn't necessarily the best choice with Kubernetes. You can actually get pretty far, like hand rolling your own, from the upstream bits. And then obviously, I wouldn't hurt for me to sort of sell myself a little bit. So, Heptio is a company that's very active in the space. We think a lot about being an upstream first Kubernetes experience. Right now, we focused on training, support, and services, and we're looking to actively build product. We put a little bit of product out in the community. You can look at a school case on it. We're going to build a lot more product in the coming months. We're going to announce another 2 product initiatives in the next little bit, which I think will be exciting for this community. And if you want to chat to me, you can always find me on the internets.
Interwebs. You're on the interwebs.
Interwebs, that's right. I think that's my presentation done. So I would love to hear questions.